In this video, we'll show you how you solve this question you see in front of you. This is taken from a specimen paper, and it is worth 8 marks overall. So on average, you should be spending about 8 minutes solving this question. So let's dive straight into it. So first off, we have log base 9 cosine 2x plus 2, and we must show that that is equal to log base 3 root cosine 2x plus 2. Now, immediately what I see is we have to show that something that's of log base 9 is equal to log base 3. So we're going to use the change of base rule. So we're going to write this as log base 3 of this. So this is going to be cosine 2x plus 2 in brackets over log base 3 of what was the base of the original, which is 9. So we're going to write it like this. Now this is going to be equal to log, give me a second, log base 3 cosine 2x plus 2. Now because log of 9 base 3 is just 2, we're going to write this over 2. Now this is essentially just half times log 3 cosine 2x plus 2. And because of how logs work, we know that if we have any number that is, let's say a number n multiplied with a log, n can also be the power. So essentially n of, for example, let's say log x is the same as log x to the power of n. So we know that this is a rule that we can follow. So therefore we can write this, what we have here, as log base 3 cosine 2x plus 2 to the power of half. And we know that anything to the power of half is essentially just square rooted. So this is equal to log base 3 square root of cosine 2x plus 2. So there you go. We have solved the first part of the question. Now, second part, we must show, hence, or otherwise show that, or actually not show, sorry, solve log base 3 to sine x is equal to log base 9 cosine 2x plus 2. Now, because it does say hence, we know that this is a follow-on from the previous question, and we know that we must use something from the previous question to help us solve. Now we have log base 9 cosine 2x plus 2, which we just proved as log base 3 square root of cosine 2x plus 2. So let's equate log base 3 to sine x to this instead of log base 9. We're going to make it log base 3 cosine 2x plus 2. So part B, that's log base 3 to sine x is equal to log base, so let's just show, so log base 9 cosine 2x plus 2. Now because we have proven the right hand side as something else, let's show what that something else is. And that's equal to what we found previously, log base 3 square root cosine 2x plus 2. Now the reason why this makes it easy is because both of them are log base 3s. Now let's apply another rule of logarithm. So for example, if you have, let's say log n of x is equal to log n of y, if we make these the powers of the base n, so essentially n log n of x is equal to n log n of y, we're essentially showing that, so what happens is the bases cancel out and we get x is equal to y. So using that same idea over here, we can solve this equation. So what we can do is, because this is base 3, we can do 3 to the power of these. So this is essentially the exponent of 3. So 3 to the power of log base 3 to sine x. Actually, going to get rid of this and write it up here. So 3 to the power of log base 3 to sine x is equal to 3 to the power of log base 3 root cosine 2x plus 2. Now, because of that rule, the log base 3 and 3 gets cancelled out like this. And therefore, we end up with 2 sine x is equal to root cosine 2x plus 2. First thing I want to do is get rid of the square root. So I'm going to square both sides, and I get 4 sine squared x is equal to cosine 2x plus 2. Now, using a double angle identity, I know that cosine 2x is equal to 1 minus 2 sine squared x. So I've essentially written cosine 2x as this. Now this makes it easier to solve. So therefore 4 sine squared x is equal to 1 plus 2. So that's 3 minus 2 sine squared x. Adding, so we move this to both. So we get 2 sine squared x is equal to 3. Now we can divide 6 from both sides. We get sine squared x is equal to 3 over 6, which is the same as a half. Square rooting, we get sine x is equal to square plus minus square root of 1 over 2, which means that sine x is equal to plus minus 1 over root 2. Now, if the domain for this question had been 0 x 2 pi, this could have been our answer. However, if you go back up and look at the question, this domain is only for the first quadrant. So had our domain been all 4 quadrants, or in other words, 0 x 2 pi, this solution would have been valid. However, we must remember that we are only limited to the first quadrant over here. So given that this is sine of x, we're looking for a positive value because the first quadrant is in the positive side on top and is not below. Therefore, we know that sine of x must be equal to, for this domain, 1 over root 2. And therefore, when we solve that, x is equal to pi over 4. And that is how you solve this question using logs and trigonometric identities.